5 minutes.
Thank you, sir. Assistant Secretary Evans, one of the things that makes Texas unique is our islanded grid, ERCOT, that I referred to, managed by, it's the Electric Reliability Council of Texas. I know you're aware of that. And it's my understanding that this allows Texas to respond more quickly to cyber and physical cyber attacks, physical threats, physical events, since they actually operate under one set of regulations, state of Texas, and of course they're accountable not to FERC, but to the agency in Texas. In your opinion, are Texas utilities more or less vulnerable because they have that kind of operating system?
I don't know that I want to actually say they're more or less vulnerable. I think that the way that Texas has approached this problem is that they're aware. And as was mentioned in some of my colleagues' testimonies where we were talking about shifting more toward risk, that they have the ability to constantly evaluate the risk regardless of whether it's a physical risk or cyber risk or a weather risk. And so it depends on how the mix works, but because of the way they're organized, they can always constantly evaluate the risk.
Right, and you're aware of that they're accountable to the PUC of Texas Public Utilities Commission as opposed to FERC, and so the state as a whole gets to kind of have control of that grid, 1 out of 9 or 8 in the country, and there's kind of a little undetermined area there. So I think it helps them work actually quicker and faster. And I do want to come back to you too. In your prepared testimony, you said that existing CSER projects in artificial intelligence, AI, and quantum technology also. So how is CSER using AI to strengthen the electric grid against cyber threats? And I want to give a part B to that question. The chairman talked about training people. We talked about young people going into these different jobs and changing jobs more often. Is CSER and the department finding that they can find young people, retain young people, and train people in AI and hopefully quantum computing?
So I'll take the second part of that question first. What we are doing as a department as a whole is that we do have an education piece associated with what is happening in CSER. We have a competition, which is the Cyber Force competition, that reaches out to all the universities. Several of the labs, 7 of the labs participate. So that's our outreach, and we are attempting to also work with the labs as well as us to then hire directly from the winners. We have a challenge, just like the rest of the government, just like the sector as a whole in this area. So we are working on creative ways through our authorities to be able to do that. On the other part of the question as to looking at how we are using artificial intelligence and quantum computing, we have several research and development efforts that are underway, but it is really to try to get it machine to machine so that you're elevating the skill level. So things that the machines can do based on how we know attack vectors will happen is to build that into the technology and into the solutions. And then have those learning capabilities then go across our data stores as it relates. So that's the artificial intelligence piece, so that then we can then feed into the intelligence sector. In visiting the labs, I can tell you that the folks that I visit there that are studying under the labs, they are very interested in how we're going about doing this, so I'm hoping that I can hire them, or they hire them.
Oh, okay, well, I appreciate that. Ms. Torres, I want to follow up with you on that. What are you experiencing in that same vein of thought?
Okay, with regards to both questions, I'll start with the artificial intelligence and some of the advanced technology concepts. So what we're seeing is the grid is evolving to the point that humans just won't be able to respond quickly enough to all the information that's going to be available to them. So they're going to have to be aided through some sort of computing, artificial intelligence types of technologies. So we are looking into concepts like autonomous systems, where we can incorporate some of the intelligence there to make decisions to maintain reliability, but also we need to do this in a way where we incorporate security from the very beginning, where we assume these systems are going to be targeted. So we are doing research in that particular space. With regards to the talent pipeline, On the research side, what we are seeing is the pipeline just is not going to be strong enough here long-term. We're not seeing enough people continuing into graduate research, their graduate studies. So we see a shortfall in folks with backgrounds in computer science, computer engineering, in electrical engineering, in the power grid. I think I heard earlier from Ms. Hamilton the fact that most of the workforce in the utility sector, they used to work their entire careers. They don't do that anymore. How can we retain folks into those areas, but also how can we retain the researchers so that we as a country can maintain leadership in these technologies that are going to shape the future grid?
All right, I appreciate that. I'm over my time. Thank you, Mr. Chairman.